Alright, it's Chili here, and it is time for Lesson 7 of the C++ beginner tutorial. Let's get right on it. I think we got a lot to talk about today. So, quick recap of the last tutorial. I didn't show you guys too much new stuff. What I did show you is the comparator here, the comparison operator. Right? Very simple. Takes two numerical values and it returns it evaluates to a Boolean value, or a true or false. So in plain English, this line here is just saying if x is greater than 794, set x to 794, right? So it eats up two numerical values and poops out a true or false. And then I gave you guys a little mission here. Let's see if this is it, right? I told you guys to make an application that goes like this, wherein the targeting reticle changes color when it is in the center of the center area of the screen. Specifically, a rectangular or square area in the center of the screen. All right. So let's see how you would go about doing that. There's actually a couple of ways. There's probably more than a couple, but at least a couple that I can think of using the techniques that we've learned to do that. The way that I would do it, and the way I was hoping that you would do it, is this way. Now, we have not done anything like this before, but I didn't say that you couldn't do anything like this. So I was hoping that maybe you would think up this construction on your own. This is what we call nesting, or nested if statements. You have one inside another, inside another, inside another. That's called nesting. And this is how we solve the problem. So I just want to go over it in a little bit of detail. So we'll whip out the Photoshop here. We've got it all set up. This canvas here is the size of our application window. So it's 800 pixels wide by 600 tall. So to find the center of our screen, we divide 800 by 2, and we divide 600 by 2, and we get 400, 300, the point 400, 300 right here. That's our center. And then to create a square region in the center here, we simply go up 100 and over 100 here to 300 by 200. And down 100 and over 100 here to 500 by 400. So that creates this, marks out our region here. And our goal is to test whether or not the cursor is inside of this region. And if it is inside, we want to change its color. So how we do that is we break it down into a number of simple comparisons. So the first comparison we would make is this one, which is saying, is x greater than 300? See here? If x is greater than 300. That's the first comparison we make. Now, if it's not greater than 300, we know that there's no way it can be inside this square region. If it's over here, there's no way it's going to be in here, right? So if it's not greater than 300, then we simply give up. right from the beginning. We just say, fuck this, let's go play basketball. But if it is greater than 300, then we know it's in this region somewhere. So we do the next test, which is x less than 500? All right. If it's greater than 300, but it's not less than 500, then it must be in this region, which means, again, it cannot be in our square. But if it's greater than 300, but less than 500, we know it's in this narrow corridor here. So we're gradually narrowing down where our targeting reticle is. The next test is in the y. Now we're going to do the vertical. Is y greater than 200? If it is, then we know we're in this region here. If it isn't, then obviously we're not in our square. And finally, is y less than 400? So if it passes every one of these tests, we know that it must be in this overlapping region right here. And the way we make it so that it has to pass all the tests is we nest the if statements. We put them inside each other. That way, in order to get to this final if statement here, it has to pass every single test. If it fails even one of these tests, then it's not going to change the color. And that's exactly the kind of behavior that we want. All right. So this is the way that I was hoping that you would solve the problem. And if I debug it here. Oh, wait a minute. Grr, it's not working. Oh, I know why. I know why it's not working. I forgot to change this one here. Quick. Just copy this here and then, yeah, okay. Don't make it smaller. All right, there we go. There we go. All right, now this should work. There we go. Okay, save the day. All right. So this is the preferred method to do things, and it's just nesting if statements, which obviously you can do and you should do. Here's a little example of nesting here. Let me just uncomment this. Just an everyday example of a nested block of code here for shaking the dew off the lily. Now, inside an if statement, we've done other statements. Up until now we've only done, I think, assignment statements inside an if. Oh yeah, we've done this too. So we've done simple statements inside an if, but you can also do function calls, and you can do anything that you could do outside of the if, really. And inside the if, you have another if here. And inside there, you have a function call. And so you can have multiple if statements within that if statement. You can have an if statement that itself contains another if statement. You can mix and match things however the hell you want. And that's what makes it so damn sexy. Okay. So this was the way that I hoped you handled the situation. But in retrospect, I realized that there is another way to handle the situation, which is basically to use the same technique that we used when we were checking to see whether the cursor goes off the screen. And that technique, just let me undo this, is not testing to see whether the cursor is inside the square, but rather testing to see whether it is outside the square. So in that case, let me think here, this one, you would test whether x is less than 300, then you would test whether it is greater than 500, you test whether, take that off, whether y is greater than 200, and you would test whether y is y is less than 200, and then you would test whether y is greater than 400. And if any of those tests pass, let me just do this. then you would change the color. So I have it saved up over here. And here we go. Just uncomment this and then tabify it. All right. And you get something like this, which is very similar to what we had for our code here for clamping to the edge of the window. So it's same idea, only in a smaller box. And if you do it this way, you will get something that is very close to correct. But you see here, we have a little problem, and that is that our cursor is white, and when it leaves the region, it gets colored. Which, makes sense if you look at this code here. This code is changing the color if it's outside the region. Just like in this code up here, we would reset X if it was outside the bounds of the window. So in order to make this this approach work properly, what you have to do is you have to invert your logic a little bit. So you have to set your default color to cyan, and then change it to white if you find that the cursor is outside of the center region. So whereas the other test was, the other code was testing to see whether we're inside the region, this code is testing to see whether we're outside. And to make them both work the same, you have to, in this approach, you have to make it so that if it's outside, it sets the cursor to white. And if it's inside, it leaves it cyan. So you have to invert your logic there a little bit, but it can work out fine. So this is also a valid approach to solve the challenge as it was given. However, I must maintain that let me just undo all this crap here. Undo. Here we go. I must maintain that this approach is the preferred approach. And the reason for that is simple here. Well, not simple, but there is a good reason as to why the nested if approach is much better. And that is, here we have the I don't know what you'd call this. The flat if approach. Whatever. Here we have the alternative approach, okay? And it works fine as long as you change your thinking and you're saying, okay, the cursor defaults to teal, and we only change it to white if it's outside of the region. That works fine, unless you let me change this here. Switch this over to green. Okay. Unless you... That's not green, you bastards. I'll kill you. I'm going to change that. Okay. Now you fucking... There we go. Let's create a new region, a second region, and we'll call this the green region, okay? Now, if you try to use the alternative approach, it's not going to work out so good, because if you default your color to teal and only change it to white if you're outside of here, then what happens for the green one? And if you default your color to green, then what happens for the teal? It doesn't quite work the same. Whereas if instead of testing for outside of a region, if you test for if you're inside a region, it's very simple. If you're inside this region, you change it to teal. If you're inside this region, you change it to green. Otherwise, you leave it white. So that's my sort of long-winded explanation as to why this approach is much better. So this is the approach we're going to be using. And this, you might think, what's the use of changing the color of your cursor if it's inside some region? I'm not going to use that much in a game, but think about it a little differently. Think this region is the hitbox on a spaceship, right? And you're making some kind of shooter game, and you've got bullets flying out. You want to check to see whether those bullets are inside the hitbox for that spaceship. And if they are inside, then the spaceship should blow the hell up, right? So that's the same idea. Testing to see whether the reticle is inside the region, or testing to see whether a bullet has hit a ship. It's the same concept. So that's why this is useful. But useful as this is, there is an even better way of doing things. It's the same way, but it looks prettier. So we're going to use that way. Let me just copy it out here. Paste this. Uncomment. Yeah, by the way, these little green sections of text that I added here, these are called comments, and I may have mentioned them before, but they're just little notes you can add to make the code easier to read. It's a little note to self, or a note to any other programmer who's looking at this stuff. And I just put them in here because the compose frame function was getting quite long. It had a long list of if statements. So this just breaks them up, and it makes it easier to see what the if statements are doing. For example, these if statements here are for clamping to the window, and these ones here are for moving the cursor, adjusting the speed, etc. So just some comments here. Nothing, no big deal. The compiler ignores all of these commented lines when it compiles the code, so it doesn't matter what you put in here. Alright, so this is what I replaced the nested ifs with. As you can see, it has all of the comparisons we had in our nested if statements. X is greater than 300, X is less than 500, Y is greater than 200, Y is less than 400. But instead of having 4 if statements, one within another, we have these comparisons, and they're all linked together by these operators. And this operator here, this is 2 characters, but it's actually one operator. It's called the logical AND operator. And to read this line, just in plain English, you would read it: if X is greater than 300 and X is less than 500, and Y is greater than 200 and Y is less than 400, assign 0 to R. That's how you would read that. Now, technically, what an AND operator does is it takes 2 Boolean values. It takes a true or false on its left, and it takes a true or false on its right. And it evaluates to a true or false. So that's different than the other operators. For example, arithmetic operator takes a number, and it resolves to a number. And a comparison operator takes a number, and it resolves to a Boolean true or false. This one takes a true or false and a true or false, and it resolves to a true or false. And how it works is if the sub-expression on its left is true and the sub-expression on its right is true, then the whole result is true. Otherwise, the whole thing is false. So for example, if this was false and this was true, this whole thing would be false. All right? And that makes sense. I mean, And means that both of them have to be true. A and B have to be true. So what this whole thing here is saying is that for this entire expression here to be true, each one of these sub-expressions must evaluate to true. So x greater than 300 and x less than 500 and y greater than 200 and y less than 400 all have to be true. And if they're all true, then this expression will evaluate to true, and we will enter the branch, enter the if statement here, or the code block for if. All right, I don't like talking that much. My throat's getting sore. My mouth's getting dry. All right, so this is the logical AND operator. Do not get it mixed up with this. Where's my backspace? Here it is. Do not get it mixed up with this. This is also an operator, but it's a little bit different. And if you write it like this, I think it will compile. Build. Yep, it will compile. Although it does give you a warning. It's not an error. But just don't do that. Remember, double ands for this one, okay? And you'll be fine. Okay, so that is how to solve the question, solve the assignment, and there's a new operator for you, the logical AND operator. Now, I want to show you guys one more operator here. So we're going to do this. No. If x is equal to 0 and y is equal to 0, whatever, r is equal to 128. That's good enough, dude. All right. So what do you think this will do? Take a wild guess. Right, so here we have our teal region, or cyan. I think this color is called cyan. Some people called it cyan. Seems right. I fucked it up kind of. So if you guessed that this will do nothing, then you're smarter than I am. Because the cursor can never get to 0, 0. It's impossible. I forgot. I'm sorry, Mama. Alright. Now, can you guess what will happen when I bring the cursor to the top left-hand corner? It changes color to a lighter cyan than this cyan. This is a deep cyan. This is a light cyan. I can't even tell the difference, but trust me, it's lighter. Alright, so this is also a comparison operator, the same type of operator as this one. It takes two numerical values and it poops out a Boolean value. However, whereas the greater than or less than check to see whether one number is greater than the other, this operator checks to see whether they are exactly the same. All right, and I mean, it's pretty, you can probably guess that just by looking at it. So this is the, I don't know what you call this, the equals operator, equivalence operator. There we go. Yeah. So never, ever, ever, ever get this operator mixed up with this operator. This is the assignment operator. This is the equivalence operator. Don't ever fucking get them mixed up. Because I know even if I tell you, you're going to do it. I have done it several times. And it is the fucking hardest bug ever to find, because I'm not sure, but let's just try to build. Yeah. This one, if you forget to double the equals sign, this one will not even give you a warning, right? It'll just compile perfectly fine. But I guarantee that it will not work the way you want it to work. And you'll be tearing your hair out thinking, where the fuck is this bug? And it'll be right here. And it's hard to see because 1 equal sign and 2 equal signs kind of look the same when you're skimming over 10,000 lines of code. It's a really hard one to miss. So I think the designers of the language, they kind of fucked it up when they chose the characters for these operators. They should have chose something a little more distinctive. Oh man, so many programmers have been fucked over by this. So from the beginning, get it in your mind never to screw up, never to mix up these two very different operators that just happen to look almost exactly the same. Okay. So that is our equivalence operator, another comparison operator for your tool bag. So let's just have a quick review here. I can get rid of this crap now. Quick review. Alright. Operators that we have learned. Here is the assignment operator. It shoves numbers into variables. Good times. Here are the algebraic, or what's the word that I always use? I forget. Anyways, here's your addition and subtraction operators, which add two numbers together or subtract one number from another. That's no. I can't remember the word I'm looking for now. No, that's gonna bug me. What do I call these operators? Arithmetic. That's the word I use. Oh, I'm so happy I remembered that. Yeah. So, assignment operator. Here are some arithmetic operators. There are other operators for arithmetic, but not too many. We've learned about half of them so far. Alright, here are... Cocksucker. Here are our comparison operators. Greater than, less than, or equals. And here is no. Here is our logical operator. So here are the operators that we have learned so far. I think that's all of them, isn't it? I can't think of any others. So there are other operators. I'll just show you them just for shits and giggles. I'll explain them as we go on. Some of them you can guess. This one's multiplication. This one's division. And this one is modulus, which is actually quite useful. And these are all, these are all the arithmetic operators for C and C++. You don't have any other arithmetic. So if you want to do something like take a sine function or exponential, then you have to, you've got to use functions for that. As for the actual built-in operators, these are all of them for arithmetic. For comparison, we also have greater than or equals to and less than or equals to. Oh yeah, arithmetic operators we also have. That's not quite the same. Forget it. I'm just talking crazy. Alright, logical operators we also have. This is an OR operator. The AND operator says that they both have to be true. OR says that only one of them has to be true. Or both of them true is also good. But if both of them are false, then the output is false. Oops. Some other operators. Brackets. Whatever you put inside brackets gets evaluated first. And exclamation mark is the not operator. Actually, that's a logical operator. It inverts whatever's inside of it. So if you put a not and then some brackets and then some expression, if this expression evaluates to true, this whole thing will evaluate to false. And if this expression is false, this is true. It's a logical knot. It inverts the logic of the expression. All right, I'm just talking crap here. You don't have to remember any of this because I'll explain these operators as we come to them. But you do have to make sure that you know these operators because I've already explained them. And if you don't know them, then what the fuck? What the fuck, guy? You're not listening to me? What? Are you too good for me or what? All right, enough talking. It's time for an assignment. Yeah, so I'm going to give you guys an assignment. And your assignment is to make a program that does this. Here's our normal, right here we have our normal cursor. But here we have a second cursor, a second targeting reticle, and it moves by itself. I am not moving this. I'm not touching the keyboard right now. It's going all by its lonesome. And your task is to make a targeting reticle move on its own. Here it's just moving on a rectangular track around the edge of the screen, about 100 pixels from the edge of the screen here. So that's what I want you to do. Make that cursor move in a rectangle around the screen. Again, like I said before, you can do this using only the stuff that I've taught you so far. And it's another step towards being able to make a little cheap ass game, right? Obviously, there's a lot of different games, things have to move by themselves, right? They don't just move because you press the buttons. Enemies and stuff like that, they've got to be able to move on their own. So, this is my new challenge to you. I don't think it's that hard, but I don't know, I could be wrong. Prove me right, wrong, I don't know. Just figure it out. And with that, I think that's the end of this lesson. So peace out, people.